The overall goal of this procedure is to characterize the temporal development and progression of autonomic dysreflexia, or AD, using AD detection software in a rodent spinal cord injury model. This is accomplished by first implanting a telemetry device into the abdominal aorta to monitor beat-by-beat continuous arterial blood pressure and heart rate. 14 days later, the T3 spinal cord segment is completely transected. Next, AD detection software is used to detect and characterize the spontaneous AD episodes. Alternatively, AD can be induced non-invasively with a Foley catheter, followed by real-time monitoring of the induced AD episodes. Ultimately, the episodic hypertension and onset of brachycardia that occurs as a result of the spontaneous or induced AD incidents can be evaluated by the AD detection software.
Allowing sufficient time for implantation of telemetry device prior spinal cord injury is crucial for animal survival, as mechanical obstruction by telemetry device cause insufficient blood flow to the hind limbs of animals.
We use the high thoracic T3 complete spinal cord injury in our protocol because it induces a number of cardiovascular dysfunctions, including autonomic dysreflexia, that resemble the clinical reality of spinal cord injury.
The AD detection software that we have developed works by identifying patterns within continuous blood pressure recordings that resemble autonomic dysreflexia, suggesting a possible use for the software in the monitoring of patients with spinal cord injury.